Right. So the biggest angle in a right triangle is the 90, right? As a matter of fact, the other two, it can be proved using the triangle sum conjecture theorem, has to be a total of 90. So they couldn't be any more than that. So it's like if you have a 90-degree angle, the other two add up to 90 together. So the biggest angle in a right triangle is the 90. What's the side opposite the biggest angle going to be in a right triangle? What do we call it? And it's always opposite the 90, right? It's called the hypotenuse, right? So opposite the biggest side in a right triangle is the hypotenuse, and the hypotenuse is always located opposite the biggest angle in the right triangle, which is the 90. So that's what this is saying, is that the bigger the angle, the bigger the side opposite, and then vice versa. The bigger the side opposite, the bigger the angle. So they correspond. So pretty simple idea here. It says write the sides of the triangle from least to greatest. So they give you a couple of angles here. They don't give you the third angle. Can we figure out the third angle? Yeah. What is it? Go ahead. Do your calculations. What is the third angle? And then we can answer this question. Because we know that whatever is the biggest angle will have the biggest side opposite it. Yeah. Yeah. So what is this angle that's left here? 83. Okay.
Look at Grace.
So
The calculator.
83 degrees. 83 degrees. So when I go to write these in order, it says write the sides of the triangle from least to greatest. The smallest length side has to be opposite the smallest angle. Okay. You might be able to just look at this picture and tell, but we really should find the angles just in case the picture's not to scale. Or if I had a couple of angles that were fairly close in measure, we wouldn't be able to tell by eye which side is the longest and shortest. So shortest side here would be SR. So we're going from least to greatest. SR is, we could use inequalities, or we could use commas, whatever. But SR, and then the next one would be ST, yep, opposite the 62 would be ST. And then the biggest side here has to be opposite the biggest angle, which is RT. And so in the homework, you're going to be asked to do that with either sides or angles. Put them in order from least to greatest, greatest to least. Just read carefully. But that's it. I think that's pretty intuitive. Makes sense. As the angle gets bigger, the side opposite that angle has to get bigger. All right, so here it says write the angles of the triangle from least to greatest. Can we do that? What's the smallest angle here?
That's hard.
Well, we were talking about angles, so you can label just one letter. So the shortest side is 7. The angle opposite the 7 is S. So angle S. Next shortest side is 9, so angle opposite that is T, and then angle R. So there it is, from least to greatest. Okay, and all this leads up to what I opened with, the idea that if I hand you any 3 lengths and say, go ahead and make a triangle out of these, connecting the endpoints, it's not always possible. There's certain characteristics of the 2 smaller ones in order to make a triangle out of those 3 lengths. So what the triangle inequality theorem says is the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. So when I handed you this pencil, this whiteboard pen, and the yardstick, it's pretty clear that the pencil and the whiteboard pen do not have lengths that add up to greater than the length of the yardstick. So there's no way I'm going to make a triangle. But that's the idea, is that the 2 smaller ones have to add up to slightly more than. Now it could be 0.00001 of an inch or whatever, or a centimeter, and it would still work. But if it were exactly the same, what would happen is these 2 pieces, the pencil and the whiteboard pen, if they're exactly the same length when added up as this third piece, then they would just touch, and there would be no third dimension. It would not be a triangle. There would be no height to our triangle. But if it's even a fraction of a unit longer when you add up the 2 smaller ones, then you do have a triangle. So that's the idea. Have you heard that one before? You guys heard of this before? Triangle, that the 2 smaller sides of a triangle must add up to, or 2 smaller lengths have to add up to more than the third length to be able to have a triangle. Do that before. Okay. So looking at these lists of lengths, I've got a 2, 2, and a 5. So first of all, I've got to identify which is the two smallest or which is the largest, therefore leaving the other as the two smallest. So the two 2's are the two smallest, and then you got to ask the question, okay, is 2 plus 2, is that bigger than question mark 5? No, 4 is not bigger than 5, so no. So what does that mean in terms of a triangle?
You can't make it.
Can't make a triangle. Okay, you cannot make a triangle because 2 and 2 add up to 4, which is not bigger than 5. So since it's not bigger than 5, it won't work.
Well, it can't be the same one.
It also cannot be the same. It has to be strictly greater than. It's like B doesn't work because we've got 3 plus 2 equals 5, which is not bigger. So no triangle possible. And C does work. So you've got 4 and 2 are the, first of all, you got to identify the two smaller ones, right, or 4 and 2. Since 4 plus 2 equals 6 is bigger than 5 centimeters, these three lengths make a triangle. Well, there will be times when it says explain. You need to be able to apply the theorem and explain why. Yeah.
Well, it says the sum of the lengths of any two sides, and 4 plus 5 is 9. And that's greater than 2. So it has to be greater than 2.
Right, but so it has to be the smaller two. Because if you put, I mean, if you switch it and say the third side is the 2 and 4 plus 5 is bigger than 2, there's no way that's going to work. So you've got to look for the two smaller pieces. And if they are not, when added up, bigger than the third piece, it won't touch. You won't have a two-dimensional triangle. It won't work. So they can't be equal. The two smaller ones can't be equal. Now they're triangle. They can't be added up and be less than the third side. They have to be greater than the third side to make a triangle. That's the triangle inequality theorem. So here's an interesting question. This is taken off of, this is like a test question. I've seen this on standardized tests. It says, two sides of a triangle measure 3 and 7. So they're leaving this kind of goes with what you're asking about. They're leaving this wide open. They're just telling you 2 of the side lengths are 3 and 7. They are not telling us that 3 and 7 are necessarily the two smaller ones. So we're not going to just say that the third side must be greater than or less than, less than 10, because it could be that 7 is the biggest one. Okay, does that make sense? Okay, so here's the deal. It says the third side must be between what two numbers? And there's a little trick for doing these, but if you start thinking about it, you have, if 3 and 7 are the smallest ones, right? 3 and 7 are the smallest ones, then I can't have a third side. Well, you're on the right track. You're thinking right. But you can't have anything that's going to be 10 or bigger. Yeah. It would have to be like 9. It could be 9.9. 9.9 would work, right? Because 3 plus 7 is 10, which is bigger than 9.9. And then you could go all the way down to 7.1 or 7.0001 or whatever. But eventually you're going to get to a spot where the 7 is no longer one of the two smaller sides. So it kind of gives you a range between 7 and 10, non-inclusive, right there. But surely there's other ones that would work, because what if 7 were the largest one? Like, could you think of a number paired with 3 that would work if 7 were the largest one? 5 would work, right? 5 and 3 are 8, which is bigger than 7. So there's another aspect over here, and I think Grayson was on here already. That's funny. Have you seen this before? Maybe, okay. So it may be in there. But here's the idea. There's a little trick to these. You can take care of these problems when they show up on any standardized test, Common Core test, SAT or whatever when you see it. And it's really simple. It's just add the two together, and that's going to be one end of it. And then subtract the two, and that's the other end. So think about this for a minute. So here's the deal. If x represents the third side, then x is going to be less than 7 plus 3. That's what we just talked about, right? It's got to be less than 7 plus 3, which is 10. And it's got to be greater than 7 minus 3, because here's the deal. So it's basically between 4 and 10. And we get those numbers by adding the 2 given to us and subtracting the 2 given to us. So think about this for me. You guys said 5 would work. Is 5 in this range?
Yeah.
Between 4 and 10, yeah. Start going down. You start going down a little more. You go to like 4.1, right? Is 4.1 going to work here?
Yeah.
Yeah, because 4.1 and 3 is 7.1, which is slightly bigger than 7.
Wouldn't
But then if you hit 4, here, 4 and 3 are equal to 7, which is not bigger than what is now the biggest side, which is 7. So anything 4 or less is not going to work. It's not going to add up enough to be bigger than 7.
wouldn't 9.9 be the biggest number?
Well, but what about 9.99 or 9.999?
Yeah.
Right? So
That's you know what I mean.
I know, I do know what you mean, but here's the thing: we can't state a specific number because of the fact that there's an infinite.
But do you understand what I'm saying?
I understand exactly what you're saying, but you can't say that. No, you have to say, listen, guys. You've got to state this inequality that has, these are called strict inequalities, which allow me to go up as close as I want to 10. So, we could just keep tacking on 9s after that decimal. There's an infinite number of numbers between 9.9 and 10, isn't that crazy? Sort of, yeah.
Why can't you just put 9.9 repeating?
Yeah.
9.9 repeating.
That's the biggest number.
Well, but that's equivalent to 10.
It's equivalent to 10 if you round up.
We're not rounding. If you have the repeating sign on
What
there,
about 9.8?
you'll go over that why that is.
9.98.
That's the idea of the limit. So, but guys, you need to write it like this, is what I'm saying. With strict inequality, and that says that it's anything up to but not including 10, and then anything down to but not including 4. Yeah.
So, you said 9.9 repeating is equivalent to 10. What about 9.98?
No, it's not equivalent to 10.
Would that work?
No. Because there are numbers bigger than 9.98 repeating that would work to make a time. So you've got to write it like that. So two sides of a triangle are 14 and 9. The third side must be between what two numbers? You tell me. Right, 5 and 23. Done. So if you can remember that, there you go. Or you can think about it. Maybe thinking about it you'll leave there, but it could take a little while thinking about it. You got to make sure that you understand that, okay, there could be a number bigger than 14 and 9 that we're thinking of the third side, but it could also be that 14 is the biggest number. Right? So kind of a neat idea there. Not terribly difficult. That's what I'm saying. I think some of you have probably seen this before. It can be introduced at younger grades. All right, it says fill in the blank with an inequality. So here we have TB, and WV. So they're asking, okay, there's WV down there. TB, WV, which do you think would be greater? Is TB going to be greater than WV or WV greater than TB? Based on that angle in between the two congruent sides. WV's got to be bigger. Why? Because inequality is this way. How do you know?
Because if it's 1.
But yeah, because the angle opposite there is bigger.
Yeah.
All right, what about here? Measure of angle 2 and measure of angle 1. Based on these sides down here.
Angle 1 is bigger than angle 2.
So angle 1 is bigger than angle 2. All right. So that's it. The triangle